Hello, everyone. We are going to go through that last day of 8.3. We have 3 days of 8.3 and then just one of 8.4 that we're going to finish up this week. We are just, and I almost put the max and min stuff on either the day one or the day two, but I thought I'd just keep it separate just to keep any one particular day from being too much of an info dump. The good news is that this stuff that we're doing today, this maximum value and minimum value, it's really not too difficult if you know how to find the vertex, because it's essentially finding the vertex. All right, so a maximum value, we call it the y-coordinate of the vertex of the graph when a parabola opens down. Okay, so when it's this kind of upside down U shape when it opens facing down. Okay, let's say we had our vertex right here. It's similar to the vertex, it's just slightly different kind of formatting. So let's say I had a vertex of 3, 7. Okay, you always want your vertex to be an ordered pair. You would say, okay, it has a maximum value because it opens down. So it has this maximum value, and you use your y-coordinate. It has a max value of 7. All right? You only either have a maximum or a minimum, at least on the graphs that we're going to talk about. Okay? You have a maximum if it opens down like this. Minimum is the same concept, except you have it when a parabola opens up. It's that right side up U. Okay, again, let's say our vertex here is 2, 1. Well, then you'd say your minimum value is 1. Okay, I'm going to show you an easy way to find whether it's a maximum or a minimum, and then I'll show you how to find that max value. It's, again, really the same process as what we were doing when we were finding our vertex on that day 1. Okay, we're going to skip over this. Here we go. Okay, maximum and minimum values. Okay, the way to tell, because it's easy enough to tell when you have a graph, it's obvious whether the vertex is the highest point or the lowest point. But when we have just an equation, the way that we tell is if our a is less than 0, which is a fancy way of saying when our a is negative, you always have a maximum. So if you're looking at that's my highlighter. If you're looking at your equation, you have y equals negative a, actually I'll use numbers. Let's say negative 2x squared plus 3x plus 7. It doesn't really matter what the rest of it is. You're just looking at your a value. If it's negative, you have a maximum. Okay, so it stands to reason. If you have a positive a value, if it's greater than 0, then you're going to have a minimum. It's going to be a right side up U. I have to use my highlighter again. All right. It's going to be, okay, let's say this is y is positive 2x squared plus 5x plus, let's do minus because it crosses at the negative. Okay. You don't really care about any other numbers in here. Again, you just care about the a value, and you're saying, okay, since that's positive, I know I have a minimum. Okay, I know that might be a little tricky to remember. Again, that's why I always let you use your student journal. You can go back and reference this page whenever you need it. Right, let's go through some actual math here. Okay, we found our vertex. That process is going to be helpful because we're doing essentially that exact same process when we're finding these maximum and minimum values. Okay, we did this graphing. All right. So tell whether it has a minimum or a maximum, then find the value. So again, the value is the y value of our vertex. Okay, let's start here with number 8. Number 8, we see, okay, we have a negative a value. That's the only thing we need to look at. You don't care about b or c. You only care about your a value. So we know, okay, that faces down. That means we have a highest point. We have a max. Okay, we can just say max and min. I know what you mean. Okay, we have a maximum value. Now I have to do the math, find out what it is. I'm going to zoom way in so I have more space. Okay, we have a maximum value. I know that the way I find that, to find the x of my vertex, we're going to use that same negative b over 2a. Okay, what's nice about the last couple of days that we've been using, we keep using kind of that same formula over and over. You don't have to memorize a bunch of different formulas. Just remember that negative b over 2a, right? So negative b, well, regular b is negative 5. So the opposite of that's going to change back to positive 5 over 2a. So 2 times negative 1/2. All right, this looks a little ugly with our fraction and fraction, but when we simplify that, it's going to be easier. Okay, 2 times negative 1/2, that's going to cancel out. That's going to end up just being negative 1. If you wanted to do the math out here, you could say, okay, 2 over 1 times negative 1 over 2. And we get negative 2 over 2. I get negative 1. Okay, this is going to be 5 over negative 1, which is just negative 5. Okay, the biggest mistake people make is they go, okay, cool, that's my max value, right? It's not your max value, it's the x where your max value happens. Okay, that's the x of your vertex. Your max value is the y of your vertex. So again, you still have to go back and plug this in to find what that y value is. Okay, so 1/2 times negative 5 squared minus 5 times negative 5 plus 2. Okay, I get negative 1/2. Negative 5 squared gets me positive 25. Okay, negative times a negative gets me a positive. Okay, negative 5 times negative 5, I already know that's positive 25 plus 2. Okay, negative 1/2 times 25. Think of it 25 over 1, so negative 25 over 2. I get some nice ugly numbers with this one. Negative 25 over 2. 25 plus 2 is 27. Okay, if I'm trying to figure out how to add 25 halves with 27, I got to change 27 to being over halves. Okay, so 27 times 2 is 54. So 54 halves minus 25 halves. I can't do mental math when it's this early in the morning. 54 minus 25. I get 29 halves. Okay, so 29 halves here as my y value. I don't know how many, I think maybe a couple of your homework problems give you that nasty of numbers, but I think for the most part, probably not. Really quickly, let's do one that looks like it might have nicer numbers. Just in case you got lost in kind of the math or the process there, let me give you one. Let's do number 8, and we can see that's number 9. Again, way too early. All right, we've got now a positive value for a. So on this one, I know my parabola is facing up, so I know I have a lowest point. I'm going to have a minimum value. Again, same process. My x is negative b over 2a. Okay, so my regular b is 16, so opposite is negative 16 over 2 times a, so 2 times 8. You get negative 16 over 16, which is just negative 1. Again, that's my x value. I want to find my y value. I'm going to plug in that negative 1. Okay, 8 times negative 1 squared plus 16 times negative 1 minus 2. Okay, negative 1 squared is just positive 1 times 8 is 8. Okay, 16 times negative 1, I get negative 16 minus 2. Okay, 8 minus 16, I get negative 8 minus another 2, negative 10. Right, so my min value, minimum, is negative 10. Right, and then very last year, I gave you a couple word problems right at the very end. I know it's been a while since I've given you word problems. We've been pretty spoiled this year. The good news about these are not the type of word problems where you have to come up with some equation after looking at a scenario. The nice thing about this is it gives you your formula, okay? This formula, this function represents your height of a rocket t seconds after it is launched. Okay, the rocket explodes at its highest point. So all of the word problems I'm giving you are basically asking something about at its highest point, at its peak. It's asking you something about the vertex. There are other things I could ask. You'll get more into those maybe in Algebra 2 with the more and more complex problems. Really, I'm always asking you about your vertex. We know our vertex is this x, y point. Your x is always going to be the time. Okay, a lot of times they'll say, when does it reach its highest peak? Or when is it at its highest or lowest or whatever? Your x value of your vertex is your time. Your y is your height or distance. Whatever it is you're measuring. Usually it's one of the two, especially with the kind of easier ones I'm giving you. Okay, so really what you need to do is look at that equation and then tell me, what is the x of your vertex? What is the y? Okay, and then it'll ask like how long is it in the air, something like that. I'm skipping those. All I want to know, again, when does it happen? When is telling me that's my x of my vertex. Okay, at what height? That's the y of my vertex. Okay, the same exact process that I've already used. Okay, I'm going to say y. Really, I guess it's h. Okay, h is equal to negative 16t squared plus 250t. If it's helpful to look at it as x and y instead of all this, your h would be your y, and you'd say, okay, negative 16x squared plus 250x. Okay, if that helps to think of it as x and y instead of h and t. All right, I'm going to find the x of my vertex, so my x, I'm thinking, okay, negative b over 2a. Right, negative b, my regular b is 250, so negative 250 over 2 times a, which is negative 16. Okay, I got negative 250 over negative 32. And let me think for a minute. Okay, that looks like it should simplify. So 250 divided by 2 is 125. 32 divided by 2 is 16. I don't think I have any common factors there. I have two negatives, so I change that to a positive. And then I can go ahead. I could leave it as a fraction. That would be perfectly fine. Since I'm going to plug this in, let me change this to a decimal. Let me make my math maybe a little bit easier. 125 divided by 16. I get 7.8125. Okay? So when I'm trying to find the height here that my rocket explodes, I'm going to plug that exact number in. I'm finding my y, so I'm going to plug that in for x or t, however I want to look at it. Okay, so I'm going to get negative 16 times 7.8125 squared plus 250 just times 7.8125. Okay. So let's see, when I square that 7.8125, I'm I'm going to stop now at 2 decimal places, so that's going to be 61.04. Okay, when I multiply it by 250, let's see what I get. 250 times 7.8125. Again, I'm going to go to 2 decimal places, so I'm going to call that 1,953.13. All right, last little bit here. I'm going to do 16 times 61.04. I get negative 976.64 plus that 1953.13. Add those together. All right. Oh, and I get 976.49. And I probably should have included units on my first one. Okay, so the first one I probably should have said seconds. And here I'm going to say it's talking about in feet. Oh, I didn't mean to move that. Oh, can I move it back? Here we go. It's talking about feet, so I'm going to say 976 feet. If the textbook doesn't tell you where to round and you end up with decimals again, I would probably round to 2 decimal places. Usually gives you the best numbers. But go ahead. You've got this last day here of 8.3. You're doing that max and min, which is really just vertex stuff, and a couple word problems that are dealing with vertex as well. Please just send me an email or anything if you get stuck, and I'll see you guys later.